I request you, madam, please try to wind up 7:30. Okay, 2 or 3 minutes. Okay, madam.
ఓకే సార్.
కొంతమంది ఎక్కువ టైం వెళ్ళిపోతా ఉన్నారు.
చూస్తున్నాను సార్.
అదే ఓకే,
టైం మెయింటెనెన్స్ ఉంటుందిలేండి సార్.
మనం హాఫ్ అన్ అవర్ అనుకున్నాం, ఒక 5 minutes అటు ఇటు ఇబ్బంది ఏం లేదు మేడం.
ఓకే సార్, నో ప్రాబ్లం సార్. Should I start, sir?
Madam, 1 minute, we will see.
Okay, sir.
Kijar sir?
Sir.
Shall we begin, sir?
Yes, sir.
Okay. So, good evening to all. I welcome all the faculty members to KSRM faculty lecture series. Today, Dr. G. Radha Madam, Associate Professor in Mathematics and the Department of Humanities and Science, is going to deliver on the topic Operations Research and its Applications. So now I request the Madam, please begin the session, Madam. Okay.
Thank you, sir. Okay, good evening, dear sirs and madams. Today we discuss about Operation Research and its applications. Coming to the outline of the course, Introduction to Operation Research, History of Operation Research, Definition of Operation Research, Applications of Operation Research, Methodology, Scheduling Problem, and Conclusion. Coming to the introduction to Operation Research, Operation Research is a scientific approach to problem solving for executive decision making, which requires the formulation of mathematical, economic, and statistical models for decision and control problems to deal with situations arising out of risk and uncertainty. In fact, decision and control problems in any organization are more often related to certain daily operations such as inventory control, production scheduling, manpower planning, and distribution and maintenance. Operations research theory makes the problems of real life more structured and hence easily solvable and having correct answers. Next, coming to the history of Operation Research, during the World War II, in the year 1939 to 1945, Britain was having very limited sources. An urgent need was felt to allocate the resource in an effective manner for the various military operations. The British and American military management invited large number of scientists, including psychologists, biologists, statisticians, mathematicians, to apply a scientific approach to the many strategic and practical problems. Historically, the term operations research originated during Second World War when USA and Great Britain's armed forces sought the assistance of scientists to solve complex and very difficult strategical and practical problems. So the term operation means the activities carried out in an organization, and the term research means the process of observation and testing characterized by the scientific method. Next, coming to the definition of operation research, Operation research is the scientific method of providing executive management with an analytical and objective basis for decision making. Here, the executive management means executive management always face some problems related to different operations like allocation of missions or use of material during the certain operations. So, such problems are solved by using the technique of operation research is defined as problem solving for executive management. Coming to the next definition, operation research is a allocation of techniques based on mathematics and other scientific approaches that finds solutions to our problems. Coming to the next definition, operation research is a systematic, method oriented study of the basic structures, characteristics, its relationships at an organization to provide the executive with a scientific and quantitative basis for decision making. And one more definition for operation research. Operation research is the art of giving bad answers to problems to which worst answers are solved otherwise. That means operation research gives the correct solution for our problem, but it does not give the bad answers to the right problems. Next, coming to the synonyms of operation research. Operation research has different names like management science, operations research, operational research, operational analysis, decision science, or simply OR. OR means operations research. Here, in any organization, more than one operation can be used. So, it is called as operations research. Is the use of mathematical models. Models nothing but reality, statistics, and algorithms to aid in decision making. It is most often used to analyze complex real world systems, typically with the goal of improving or optimizing performance. Next, coming to the applications of operation research, allocation and distribution in projects. So, optimal allocation of resources such as men, materials, machines, time, and money to projects. Project scheduling, monitoring, and control. Determination of proper workforce and development. Next, production and facilities planning. Estimation of number of facilities required, factory size, and allocation decision. Selection of transportation route. Next, programming decisions. What, when, and how to purchase to cost.
Excuse me, madam.
Yes, sir.
Excuse me, madam. The PDF is not moved, madam. No. Applications
Okay.
of OR.
Yes,
It is
sir.
stopped at that.
Now, sir?
Please, same slide, madam. Applications of OR.
Yes, sir. Applications of was now continue.
Okay, okay, fine, madam. Okay.
Okay, sir. Bidding and replacement policies. Next, marketing, advertising, budget allocation, selection of advertising media, customers' performance of size, color, and packaging of various products. Next, organization behavior, selection of personnel, determination of retirement age and skills, recruitment policies and assignment of jobs, recruitment of employees, scheduling of training programs. Next, finance, capital requirements, cash flow analysis, credit policies, credit risk, etc. Investment decision, profit plan for the company. Next, research and development, product introduction, planning, control of R&D projects, determination of areas for research and development, selection of projects, and preparation of their budgets. And the next one, environment, medical, etc. are the applications of operation research. Next, methodology. Methodology means the steps which are taken in order to solve problem with the help of operation research. Under the methodology of operation research, we will discuss 6 particular steps. One is problem formulation, and the next step is constructing mathematical model. Next, deriving solutions from the models. Next, testing the model. Next, establishing control over the solution. Next, implementing the solution. So here first step is problem formulation. Here we define any real world problem very clearly. But it is impossible to obtain right answers from the wrong problem. In formulating the problem, objectives, alternative course of action, constraints, and effect of the system under study must be established. Coming to the next step, constructing mathematical model. So our problem is converting into mathematical model of the problem with the following basic elements. So here first we can define decision variables. So decision variable is one that can be directly controlled by the decision maker. The value of these variables are to be determined. And the next, here we can define the constraints or restriction. The model must include constraints in order to check physical limitation of the system. And finally, to write the objective function, that is mathematical expression of profit or cost for a particular operation. Next, coming to the deriving solutions from the models. So here to determine of those values of the decision variables that optimize the given objective function. Sometimes it is profit related. Our objective function must be maximization type. Sometimes our problem is cost related. Our objective function must be minimization type. To determine the solution, either by simulation or mathematical analysis. Mathematical analysis for deriving optimum solution includes analytical or numerical procedure and uses various branches of mathematics. Simulation models gives us computer-based solutions. Next, coming to the testing the model. So a model is valid if it can be proved a reliable prediction of systems performance. A good operations research analyst continuously tries to update his model. Next, coming to the establishing controls. It satisfies our problem nature or not. Suppose it satisfies, we can implement the solution. Sometimes it does not satisfy our problem constraints. In that case, the analyst must once again we can modify the problem. After that, the implementation of the solution. So solution so obtained should be translated into operating procedure to make it easily understandable and applied by the concerned persons. After applying the solution to the system, work group must study the response of the system to the changes made. So in any problem solving, that is a linear programming, we must follow these 6 steps. First, we can define real life problem, any real life problem. Next, to convert it into mathematically. Next, to calculate the solution for the decision variables. Next, to test the models. After that, establishing controls over the solution. Here, testing. Next, any modifications is there. Here, we can modify. After that, we can implement the solution. Next, one example for scheduling problem. A college requires different numbers of employees on different days of the week. Each employee must work 3 consecutive days and then receive 4 days off. Formulate LP. Here LP means linear programming to minimize the number of employees who must be here. So here given in each day, the number of employees required on Monday, 16 members, on Tuesday, 12 members, on Wednesday, 18 members are required, on Thursday, 13 members are required, on Friday, 15 members are required, and Saturday, 9 members are required, and Sunday, 7 members are required. But in this problem, to minimize the number of employees, but and one more condition is given. Each employee must work 3 consecutive days and then receive 4 days off. Each employee must work 3 consecutive days and then receive 4 days off. But here to formulate linear programming to minimize the number of employees. So coming to the solution. So here first we can define the decision variable. Here decision variables means we can define the number of employees beginning to work on day I. So there are 7 days. So X1 be the number of employees beginning to work, here taken as X1, be the number of employees beginning to work Monday, Tuesday, and Wednesday. X2 be the number of employees beginning to work Tuesday, Wednesday, and Thursday, and the remaining 4 are off. Next, X3 be the number of employees beginning to work Wednesday, Thursday, and Friday. Next, X4 be the number of employees beginning to work on Thursday, Friday, and Saturday. Next, X5 be the number of employees beginning to work Friday to Sunday. Next, X6. So he must work on Saturday, Sunday, and Monday. And X7, he works Sunday, Tuesday, and Monday. But the number of employees required on Monday is 16. The number of employees required on Tuesday is 12. The number of employees required on Wednesday is 18. The number of employees must work on Thursday, 13. Next, Friday, 15 members required. Saturday, 9 members are required. Sunday, 7 members are required. Now, to convert this data into mathematically, so first to write the objective function, but here to minimize the number of employees. So our objective function is a minimization type. So here to minimize the employees, so minimize z is equal to x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7. Next, to write the subject to the constraints. So according to this table, x1 plus x6 plus x7 greater than or equal to 16. Next, Tuesday, x1 plus x2 plus x7 greater than or equal to 12. Next, Wednesday, x1 plus x2 plus x3 greater than or equal to 18. Next, Thursday, x2 plus x3 plus x4 greater than or equal to 13. Next, Friday, x3 plus x4 plus x5 greater than or equal to 15. Saturday, x4 plus x5 plus x6 greater than or equal to 9. Next, x5 plus x6 plus x7 greater than or equal to 7. But here x1, x2, x3 and so on, x7 be the number of employees. So it is always positive. So where xi greater than or equal to 0, I varies from 1 to 7. These are non-negativity restrictions. So first we can define the problem. Next, to express the given real world problem into mathematically. Next, to calculate the solution. So here applying either simulation model or mathematical model, we get the optimal solution, or using operation research models, we get the optimal solution. So here the optimal solution is 31, and one of the is given by x1 is equal to 11, x2 is equal to 0, x3 is equal to 10, x4 is equal to 3, x5 is equal to 2, x6 is equal to 4, and x7 is equal to 1. So solution is obtained. Next, comparing this solution with the constraints. So substituting these values in the first constraint, it will be satisfied. Next, second constraint also satisfied, but the third constraint is not satisfied. It is the redundant one. Next, constraints also satisfies. Next, also satisfies. Next, constraint also satisfies. Next, constraint is also satisfied. Testing the model, this means. Next, establishing the model, but here the redundant one is there. So again, we can control the given problem. After that, we can implement the solution. Next, conclusion. Operation research is used to solve complex problems of business Through mathematical analysis, this technique is used in various fields of agriculture, production, and business management. It also supports in improved competitiveness of the organization through strategic business decisions. Any queries?
Yeah. Thank you, madam.
Thank you,
So
sir. Okay, sir.
I
Thank you,
request
sir, for giving this opportunity for me. And also, I thank our management, director, principals, various departments of HODs, deans, and coordinator of lecture series and team members, and my colleagues and students. I thank, and
yes.
also I thank for listening patiently
Okay.
my lecture.
Thank you, madam.
Thank
Any
you, sir.
queries from the participants? Madam,
Yes,
can
sir.
you name a few solutions, madam? The name of the solutions to get the optimum,
Simplex method, sir.
madam.
Simplex method, war model, simplex method, sir. But nowadays it is using Python also, sir.
Okay, that is the implementation, madam.
Yes,
The
sir.
techniques,
Yes, sir.
simplex
Simulation
method.
models, sir.
Okay,
Simulation models, sir, and also mathematical models, sir.
okay, okay. So I thank all the participants. Thank you, madam.
Thank you, sir.
With this, we will close this session.
Okay, thank you, sir.